Welcome back to the new week of physics lecture. In this lecture, we will start to focus on our part analysis in order to succeed in our examination. In this week lecture, we will be discussing everything about dynamics. Do you remember that in previous week's lecture, we discussed everything about motion, which is guided by Newton's first law. In this one, we will be talking about dynamics, which is guided by Newton's second law of motion. Have you ever tried to solve anything like this or anything like this, and you find it so technical, you don't know how to go about it? In this lecture, you are going to see how we can break everything into bits and bytes that will enable you to solve things without fear at all. I must let you know that what you are about to deal with is a world of vector. So your vector knowledge is very, very important. And I must repeat, it's very important that you understand your vector very well, especially the areas of resolution of vector, as well as how to find the direction of a vector. That's the reason why we will start with vector revision in this course. Let's begin. What is dynamics? Dynamics is a branch of mechanics that deal with force and their relation primarily to motion. So we are talking about force and motion, basically. It's no more than that. So in dynamics, there is nothing that we are doing than what? Look at force as well as what? As well as motion. That is two things that define dynamics. These branches of mechanics, this branch of mechanics is governed by Newton's second law of what? Newton's second law of motion. Second law of motion, which states that F is equal to ma. What is the meaning of this? Force acting on a body of mass m is directly proportional to the rate of change of momentum, and it is in direction of the motion of the object. Two things that you must know. At least we broke it down into three. Force acting on the body of mass is directly proportional to the rate of change in momentum, and it is in direction of motion of the object. What is the meaning of momentum? That is what? Mass over velocity. Momentum is mass multiplied by velocity. When it becomes rate, we divide it by time. That's what? Time rate. And I must let you know that what the meaning of this is just what? Open bracket V2 minus V1 close bracket divided by open bracket T2 minus T1, you close the bracket. So everything that you see here is equal to mass times acceleration. This is the mass, while this is velocity over time, which is acceleration. So therefore, the second Newton laws of motion is actually talking about momentum change, which is what? Change in motion in actual sense. Since the basic backbone of this concept is force that acts on object, it is very important to look at various types of force that can surround an object. Force is a vector, and vector is a straight line, horizontal, vertical, and slant. So we must look at that because vector is a straight line. I get it now. So we need to look at what vector is all about. Well, what we want to look in the vector is actually the direction of vector. We have talked about this one in the previous lecture, but we need to do summary. We need to do review so that you understand more basic things about vector. Some students are doing some kind of mistake. Wow, and I've said it in last class. Yeah. Okay, but we are going to repeat it. Now here, it is some experiment that you've seen in the previous lecture where we demonstrate the parallelogram law of forces. That is two vectors that can be represented, that their adjacent side can be represented in imaginary direction by the what? Parallel side of the adjacent side of the parallelogram. So in this case, what do you see? You see this mass that represents force P, this mass that represents force Q, and this balance mass that keep them in equilibrium. So what do you need to pick? This one, this one. So this Y shape is our force together. So in this scenario, we want to see what is the meaning of resultant and direction of force. Let's move on. You see, if you pick at all these forces, you are going to form something like this. So this one, as well as this one. So using that particular law, parallelogram law, you have to extend this one ahead If you extend this one, it will you not complete the parallelogram. So in the parallelogram, opposite sides are equal and parallel, isn't it? So in this case, you can extract one triangle. Are you getting me? You can extract one triangle. But note, every vector must make sense. That is to say, they must start from a source and go to the what? Destination. The source is the tail, the destination is the head. If you could ask yourself that where is the tail, where is the head, all of this vector, I don't really know. But what you need to know is that this force will pull this road down like this, while this force will pull this road down like this. Are you getting me now? Why this one will pull both of them down. So this one is traveling this way, why this one? So this one is this one, and it is traveling along this path. Do you see? Along this path, I don't know, maybe you actually get what I'm talking about. So, but let me illustrate it to you. Let me use white chalk all over this place so that you can get what I'm talking. This vector would travel like this, and in order to trace that direction like this, you see, it will be like this. I get me to now travel in this place. Why this one will also travel in this direction? So this line is this line here. Are you getting me? Why this line is this line here? So why this line? This one will travel downward. So in this time around, what we are saying is that this vector will travel in this direction, while this vector will travel in this direction. So this is the tail of this vector. This is the tail of this vector. Are you getting me now? This line of vector here, this line of vector, this is the tail. So the vector will go from the tail and trace back to the head. Are you getting me? So if you look at this one here, this is the tail, while this is the head. So it will be traveling in this direction. If you want to take this particular triangle, are you getting me? This is the tail. Automatically, it will be traveling in this, which is what? Which is the head, according to the parallelogram law. So what we are doing is that we are converting the line of forces into a parallelogram shape where we can extract triangle in order to enhance our calculation. So what do we need to do? We just need to take out this particular triangle here. If you pick out the triangle, what are we going to get? We are going to get something like this. I'm so sorry. I'm so sorry. So, okay, I think I tried. Okay. So in this case, what is the angle of this particular resultant vector? You are going to draw a 4 cardinal points at the tail, and you will trace from the angle of 0 to the vector. This angle, it is the angle of the vector. Are you getting me? You will trace it from the positive 0. This is 0, and you travel in the positive direction until you meet the line of the resultant vector. For this vector, its own angle will be from positive 0 to this line of the vector. But what about this one here? You are going to locate its tail, and you draw 4 cardinal points. Are you getting me now? You draw 4 cardinal points, and from there, from the angle of 0, you travel in positive direction. This is positive 0 direction. So that is its own angle. Some vector may fall in the 3rd quadrant, so their own direction is this one. Are you getting me? That is the direction of vector. You will start from angle of 0, trace it in clockwise direction. But most of you will say that Shebi, what we have is sine theta all over cos theta. I know you have sine theta over cos theta, but look at it. This is what you have. This is what you have. This is what you have. You have a vector in the 1st quadrant, and you complete your triangle, your right angle triangle. Automatically, what will be the theta? So this theta, it is the angle of this vector. Are you getting? And this is the resultant vector. Are you getting now? To now find out the angle of this vector is equal to what? Sin theta over cos theta, which is equal to what? Tan theta, which is correct. Which is correct. But if the vector fall in this place, are you getting me now? Your angle will be in this place. Your angle will be in this place. which you can still use sin theta all over cos theta. But in this case, the theta that you get here, it is not the real angle of the vector. It is not the real angle of the vector. The real angle of the vector, it is this particular angle. It is this particular angle here from this place to this place. Are you getting me? That is, by subtracting this angle from angle 180, you are going to get the real angle of the vector, because the line of the vector now falls in the second quadrant. You will trace from the angle 0, are you getting me, in positive x direction. That is that is the angle of the vector. You must know exactly what you are doing. If you don't know it, you won't know what to find. Angle of every vector started from what? A 0 angle in positive direction. Are you getting me? So from this point of view on now, this vector we can find the resultant of this vector by applying cosine rule. And any missing angle, we can use sine rule to find it. This is what I mean. You are going to see what I mean in more details. So this is what I mean. This is two vector, that is their resultant. You draw the parallelogram. Are you getting me? So this one is equal to this one is equal to this one. But what you can be given is the angle between the vector, which is angle theta. But this angle, are you getting me now? We can extend it by using alternative angle theory. Do you remember how I told you about alternative angle? Euclidean geometry is very, very important. Now, you know that according to Euclidean geometry, he said that let us have parallel lines. And this is parallel, Abi. So let us have a transverse line. If you have a transverse line, automatically it's another parallel lines. The guy said that if you can draw Z angle, if you can draw Z line, draw a Z line, let me try to make this thing clearer. Okay, now draw Z line, can you see Z line? Okay, if you can draw Z line, what is the implication? Angle inside of the Z is equal to angle outside of the Z. This is what they call alternative angle. If you could look at this place, if you can look at this place very well, So extend this one, Have you extended it? So this is parallel lines now. This one, this line, and this line are parallel lines, and I extended it. Now let me now trace my Z line on it. To now trace my Z line, let me use another ink. If I want to trace my Z line, this is my Z line now. Do you see? So my Z line has taken the angle theta and it has matched it with this. You remember that this theta now will now be what angle in this place. Therefore, what will be the angle in this place? So angle in a straight line is equal to what? 180. This is equal to what? 180 degree minus theta. So in this case, what have we done? Let us take out this triangle. Which triangle? This is line A, this is line B, this is line C. Let us take out the triangle of line A, line B, line C. We can now see that this triangle forms something like this. Let me take my white chalk so that you can see what I want to do. Oh God. Now this angle here is now equal to what? 180 minus theta. I told you that in a triangle, every line faces its own angle. This is the resultant line. The angle that faces it is this. Are you getting me now? This angle, it is not the angle of the line of the vector of the resultant. You should note very well. It is not the line of the angle of the what? Of the resultant. This is our resultant. Are you getting me? In this case now, we assume that it falls on exactly 90 degrees. That is to say, from this place to this place, you will start from a 0 degree in positive x direction. Are you getting me now? So in that scenario, this one is the major angle. But when it comes to isolating the whole triangle, the angle that faces that particular resultant is the angle of the line. It is not the angle of the vector. So that is the reason why whenever you are given angle between this vector, they use 180 minus theta to do their computation. What do I mean? How do I mean? This is line A, this is line B, this is line C. If this triangle form right angle triangle, it will have been C square. Sorry, let me okay, this is C, Abi. It will have been C square, which is resultant, is equal to what? A square plus B square. But if it is not right angle triangle, we are going to use cosine law, which will now be minus 2BA cos 180 minus theta. What are we looking for? We are looking for C. So this one must be the angle that faces C. If we are looking for A, this one must be the angle that faces A. Where is the angle that faces A? This angle will face line A, while this angle will face line B. So in a triangle, every line faces its own angle. Please note that. So if there is any angle that you are looking for, you can use sine rule to tackle it. That is to say, sine A all over line of A, because sine A, it is the angle that faces line A. So now this is line of A here. Let me use line of A here. So this is the angle that faces A. We are going to use it as capital letter. Let me use this place as capital letter A so that it will be like that. So this will be equal to what? Sine B all over line of B. Sorry, line of B. This is equal to what? Sine C all over what? Line of C. So if I look at sine C, it is what? Angle of 180 sine 180 minus theta all over divided by what? Length of line of C. This C is equal to the length of the line. So all of this is the length of the line, how long the line is, while this is the angle that faces those lines. So we can solve two at a time that we know that it is solvable. Are you getting me? We can solve two at a time that we know that it is solvable. Those one that we can see there, that we can see that yes, they can be solved. In this case, this is how you can find any missing angle as well as resultant, as well as identify the angle of vector. The angle of every vector is traced from the 0 degree in positive x direction. In positive direction. Are you getting me? So now, what is this animation is trying to tell you? If you look at this vector, this is a line vector, slant vector. You remember we said that vector is a straight line, and there are three types of straight line: vertical line, horizontal line, and slant line. If this box I apply a vertical force to it, this box will only move in vertical direction. If I apply horizontal force to it, it will only move in horizontal direction. But if I apply slant force to it, what happens? It will move vertically and it will also move horizontally. That's the reason why distance between the vertical and horizontal will tend to decrease at particular points in time. You can see that at a point in time, the vertical and horizontal distance is decreasing. That is the meaning of slant force. The force that moves an object in 2 dimensions, if we are talking about 2-dimensional coordinates. In this scenario, you can now see that this vector, we can separate it into what? Vertical components and what? And horizontal components. And you know how to separate angle, how to resolve angle into horizontal components and vertical components. You must note where your angle is angle with respect to horizontal or is angle with respect to vertical. Let me clear the board to let us see what we are going to get. Let us see that, okay, this is the vector. Are you getting me now? We resolve it into what? Vertical component and horizontal component. If the angle is between horizontal and the line of the vector, are you getting me now? So the vertical line is equal to what? Sine theta. While the horizontal line is what? Cos theta. So you can now do that to resolve vector into their components. Some students asked me some question in our previous lecture that, sir, what we have discussed in our previous lecture is about one-dimensional motion. What about two-dimensional motion, three-dimensional motion? Listen, everything is so the same. If you know how to find the resultant of anything, you are there. So you remember, if we have velocity, which is equal to what? Displacement all over time, isn't it? So we are talking about resultant displacement all over total time. So you cannot have displacement on x-axis, displacement on y-axis, displacement on z-axis. You know how to find the resultant of a vector using Pythagoras rule. Find the resultant, put it here, then put your time. You are going to get your velocity. So what we are doing is not so complicated. It's very simple. Once you know the simple one, you can use it to scale the complicated one. So this is the diagrammatic illustration of what we have just solved now, that every triangle in a triangle, angle face its own line. We can use cosine rule to find the resultant and sine rule to find the missing angle. Are you getting me? You can see in this place, angle C face line C, angle B face line B, angle A face line A. So assuming that you have these three vectors, where theta is equal to 30 and beta is equal to 30, while alpha is equal to 60 degrees. Can you find the resultant of this vector? Of course, you can find the resultant of the vector by resolving each of these vectors into vertical and horizontal components. Let us look at this vector. In order to resolve a vector into horizontal and vertical components, you need to know the tail of the vector and the head of the vector. So let us take this particular vector here. This is the tail of the vector. I will trace it to horizontal and I will trace it back to vertical. What happened? I am traveling from the tail to the head, which is the normal directional traveling. In this case, this is a right angle triangle, which I can find the vertical component as well as horizontal component. This is the resultant. So that is to say, my vertical component will be equal to what? My vertical component of the vector is equal to what? Is equal to the resultant of the vector, which is equal to what? 725. Yes, what is it? This angle is with respect to horizontal. We don't have any problem. That is to say, multiply by what? Sine 30. So what about the horizontal component? The horizontal component will now be, this is Vy, while this is Vx. So horizontal component is going to be 725 cos what? Cos 30. Now, what do you want? You will take the sum of the what? You will find all the horizontal components. You will find all the vertical components. You will now find the sum of the what? Horizontal components and what? Sum of the what? Vertical components. By doing that, you are going to apply Pythagoras principle to this. Note that whenever you are doing the sum, appropriate sign must be allocated. In this case now, this one horizontal component is negative, while the vertical component is what? Is positive. You must put appropriate sign so that you won't do any mistake. That is that about that. I must let you know that by the time you find your resultant, you will get where the resultant is located by looking at the sign of the y component as well as the sign of the x component. By the time you sum everything up, maybe we should try to do this so that we can get illustration of what we are really talking about in this particular scenario. So how do we do this? If I am a YX student, how do we do this in order for me to get my maximum mark? So what I will do is that I will try to draw a table. I will try to draw a table. I will look for, I would say that's my S component vector of individual, and I'll say that my y component of vector individual. So I will now list all my vector. The vector 1, which is what? The vector 1 is what? 725, and the angle is what? 30 degree. By the time I look at how to find the resultant, I can see in this scenario that my Vx, my horizontal component, you know that x come before y. That's the reason why I write Vs before Vy. My Vs is equal to minus 273 multiplied by cos 30, because theta is equal to 30 degree as it's given in this place. So what do? We say that 725 multiplied by cos 30. Answer is equal to 627.9. 627.9. And if you look at direction, it is in negative direction. What about y component? Y component in positive direction, which is equal to what? 725 multiplied by sine 30. Multiplied by sine 30. What are we going to get? Answer is equal to 365.5. 362.5. So this is positive direction. Let us look at second vector. Second vector is 500 Newton. Are you getting me? You can put their units here. You won't have any problem. In fact, using this method is one of the best methods that is easier for every examiner to mark. And if you can do this, you will get your maximum mark. Are you getting me? So we have 500. The one that is of 500. Let us see what are the components. This is the tail of the one that is 500. You trace it horizontally. Are you getting me? Like that. And you trace it vertically. So you trace it horizontally and you trace it vertically. So horizontal component is negative. Vertical component is also negative. So the line, the angle is between the horizontal and what? And the line of the vector. That is, vertical is equal to sine, horizontal is equal to what? Cos, which is very good thing that we actually looking for. So, and the angle of what? Is it not theta? Where this is beta, this is angle, no, this is angle alpha. Angle alpha is equal to 30 degree. Abi? No, angle alpha is equal to 60 degrees. Sorry, this is angle alpha, which is equal to 60 degrees. Please, you must watch very well. It's very, very important. Okay, so angle alpha is equal to 60 degrees. Now let us now look at that. We now have 500 multiplied by cos 60. 500 multiplied by cos 60 should be equal to 250. 500 multiplied by cos, is it cos 60? Yes, we have cos 60. So that is 250, and it is negative minus 250. And for the vertical component, it will be sine 60. It will be sine 60. What is answer? Answer is equal to 433.0. Negative 433.0. And the last one is what? 780. Vector 780. So for vector 780, what do we trace? You locate the tails, trace it along the head. So that is positive, while this one is negative. So the angle is between the vector and horizontal. So the vertical is sine, horizontal is what? Is cos. Good. So let us now see. Beta is equal to what? 30 degree. So for the horizontal component, we have 780 multiplied by cos 30. 780 multiply by what? Cos 30. So what is answer? Answer is equal to 765.5. 765.5. Sorry, 675.5. Is it positive or negative? X like that, it is positive. So it is positive. And what do we are now going to say? 780 multiplied by sine 30. 780 multiplied by sine 30. What is answer? Answer is equal to 3. Answer is equal to 390. 780 multiplied by sine 90. So multiply by sine 30, sorry. 780 multiplied by sine 30. We have to be very sure. So this is 390. Is it positive or negative? Pointing downward, that is negative. So let us find the sum of our x and let us find the sum of our y. Let us add them together. So this is minus 627.6 minus 250 plus 675.5. What is answer? Answer is equal to what? Minus 202. Minus 202 point, is it point anything? 0.0. No, let us try again. Maybe 0.1. It should be 0.1. It should be 0.1. So this is 202 minus, sorry. This is minus 202.1. What does it tell you? The x component is already in the negative direction. Let us now look at our y component. For our y component, what are we going to get? We should be looking at 362. Yes. 362.5, yes. Plus, no, it is minus 433.0 minus again 390. What is answer? Answer is equal to minus 460.5. Minus 460.5. You see, x component in the negative direction, y component in the negative direction. Where is that? That is third quadrant. So resultant vector is in third quadrant, where x is negative, where y is also negative. In this case, we don't know the length yet, but we have known where it is located. So let us now find the length. We are fine. So you square this, use your Pythagoras theorem, square this, and find their square root. So what we are saying is that we are looking for square root of what? 202.1 square plus, because square of any negative number is equal to what? Positive number. Remember, 460.5, that should be square. So what is answer? Answer is equal to, when I take the square root, answer is equal to what? 502.9. So the resultant is 502.9 Newton. That is how long this vector is. That's one aside. What is the angle of the vector? To find the angle of the vector, we need to find the angle in this place first. Are you getting me? How do we find the angle in this place? We know that our horizontal component of the vector, this is our horizontal component. Are you getting me? This is our horizontal component, which will be here. Are you getting me? Oh, sorry. I don't like the way this marker is doing. So, okay. We have horizontal components. Are you getting me? Because you identify the tail and you trace it from the tail to the head direction. Are you getting me? So you know that this one is also equal to this one because opposite sides are equal and parallel. Are you getting me? So our horizontal component is what? Minus 202 point what? 0.1. And our vertical component is what? Minus 460.5. So according to the principle of finding the angle of a vector, this is opposite, is that not it? This is opposite, this is adjacent, because the angle of that vector is equal to what? Tan theta is equal to what? Opposite all over what? Is it opposite all over adjacent? Yes, opposite all over adjacent. Right, I'm right. And the opposite in this case, do you now see the reason why? Opposite in this case is equal to what? Is equal to 202. You must be very, very careful. It's equal to 202. Are you getting me? 0.1 divided by what? 460.0. What happened? Negative will cancel the negative. So let us now look at our angle. Our angle is equal to tan arc. Tan arc 202 divided by, we need tan arc 202 over 202 over 460 let me be sure of something. Okay, 202.1. It is 202.1 over 460. You have to be very, very careful. 0.5. What is answer? Answer is equal to 23.6, 23.7. Jesus. So answer, this is tan arc 202.1 over minus, minus will cancel minus. We are just putting it to make sure that we know what we are doing. All these step working are very, very important for every WAEC student to attain your maximum score. So our angle is equal to 23.7. Although that is our angle, but it is not the angle of the vector. The angle of the vector starts from where? X in clockwise direction. Are you getting me? So, and the sum of the angle along this place is equal to what? 270. To now get the remaining of this angle, we say that 270 minus what? 27.3. So the angle of the vector now, which is this particular angle here, is equal to 270 minus 23.7. What is answer? 270 minus 23.7. What is answer? Answer is equal to 246.3. 246.3. Now, with this illustration, it should now be clear to you, WAEC students, on how to find the resultant and direction of a resultant vector. How to find the magnitude and direction of a resultant vector. Because if you have something like this in your objective, all this proper breaking down is very, very important. Now, in this case, this is another illustration to show the correct angle of the resultant vector. Do you see that? This is our resultant vector. Look at where the angle started from. Do you see? Do you see? From the positive is 0 to the line of that vector. And to many students, if they give you this question in exam, this is the angle that you'll be calling angle of the vector. If you call this one the angle of the vector, I am so sorry, you are on your own. It is not the angle of the vector. And I'll be telling you, if you want to find the angle of the vector, you must be able to resolve all the components into their horizontal and vertical components. Are you getting me now? And for you to get the resultant right, you need to work appropriately in order to get the actual angular implication. That is that about that. For this one, if you want to do that, this particular vector now is at angle, is at a particular angle. Are you getting me? It's at particular angle because this line here represents our 4 cardinal points. Okay, so you need to find the angle of this vector with respect to horizontal. You need to find this particular angle, and if it is to this one, you need to find this particular angle. It will enable you to resolve each of the P and Q to their horizontal and vertical components. And by the time you do that, you should be able to get the sum of the horizontal component and the sum of the vertical component that you can use to find the angle that is related to the angle of the vector. Okay, so let's move on. This is another example, but you are going to do this by yourself. I'm not going to help you to do it. I will just explain. Two forces Two forces, 5 Newton and 3 Newton, incline at angle of 30 degrees to each other. What is the meaning of that? This is what? 5 Newton. This is what? 3 Newton, angle of 30 degrees to each other. Find the magnitude of the resultant vector. You can do that by applying your cosine rule. Find the component of the resultant vector. Yes, this is where you have work to do. After finding the magnitude of the resulting vector, in order to find the resultants, in order to find the component, you need to find the direction of that particular vector. After finding the direction of the vector, that will be the angle, then you can now resolve the vector into horizontal component and vertical component. Please, I want you to try by yourself. It is not that technical. Please, I want you to try. Okay? So this is the first aspect of this dynamics. In the next class, we are going to continue where we'll be analyzing the dynamics into vertical component, horizontal component, as well as slant component. Therefore, we will look at how to solve the horizontal component, how to solve the vertical component, and how to solve the slant component before we look at how to solve the mixed component. Thank you for listening. ABP.